All right, here are the bonus questions from the midterm for Chem 1030. Draw the products of the following reaction, name the reactant and product. This is a reaction across the double bond, big ol' hint, and Br2 acts like H2 in that it adds to the two positions across the double bond. So I end up with the same structure with only a single bond, and there would be a bromine on each carbon. That was part of that double bond. Name the reactant and product. If I come over here on the left, that is a 5-membered pentene ring. Let me write that over here. This is pentene because of the double bond. It has a methyl group in one of the positions. And it's not just a pentene, it's a cyclopentene because it is a ring, cyclopentene. I would number it with this being the 1 carbon. This would be 2, but I don't have anything else to put on it. So I can name it as a cyclopent 1-ene or a 1-cyclopentene. I can do it either way, or a cyclo-1-pentene. And then in the 1 position, there is also a methyl group. So 1-methyl cyclopentene, 1-methyl, 1-cyclopentene, 1-methyl cyclopent 1-ene would have been acceptable. In the product side, this is also a cyclopentane now because there are no double bonds. There are bromos in 2 positions. This is either 1,2 or 2,1, depending on how I want to name it. Since there are 2 constituents here, I'll name this as my first carbon and this is my second to get a lower numbering system. So it is a cyclopentane. That's the end of it. In the 1 position, there is a methyl. And in the 1,2 position, there is a dibromo. And then I'm going to name them alphabetically. So it'll be a 1,2 dibromo, 1-methyl cyclopentane. All right. Second bonus question, draw the products of the following reaction. What is the name of this reaction? When we have this arrangements, essentially what's happening is we are condensing this. This is a condensation reaction where we are taking water out. It is drawn in exactly the right place that we need to see what's happening. So there's the guy on the left. This was going toward the oxygen. One of these oxygens is taken out with the OH. Again, if I have an H, that's my H2O. I'm removing water from it. And then it joins with the other side. So I've still got that 6-membered ring there. And my other product then is water. So again, it's a condensation reaction. I remove H2O and join the 2 pieces together. This bonus question was a recall, soluble fiber versus insoluble fiber. Soluble fiber, apples, carrots, psyllium husk. You can look those up in the textbook. And insoluble fiber, cellulose, cabbage, vegetable stalks, etc. Take a look at the video lecture that went along with this to get more. All right, so several would have been accepted there. And then this last bonus question, calculate the mass in grams of oxygen. How many grams of oxygen is in 24.3 grams of sodium sulfate? Sodium is +1, sulfate is -2, and so the formula of sodium sulfate is Na2SO4. All right, to work this problem, I need to cancel the grams of sodium sulfate. Trying to get to grams of oxygen, but I gotta go through moles. So I'll have moles of sodium sulfate on top. in 1 mole. I look up the molar mass from the periodic table. That's 2 sodiums, a sulfur, and 4 oxygens. If I add that together, I get about 142. And then I'll do my mole to mole step. So moles of sodium sulfate on bottom to cancel. I'm trying to go to grams of oxygen, so I need moles of oxygen on top. And in every one of these molecules, there are 4 atoms of oxygen. So 1 mole of sodium sulfate gives me 4 moles of oxygen. And then one last step, I take moles of oxygen to grams of oxygen using the molar mass from the periodic table. Multiply that all together. My calculator says something like this. This is grams of oxygen, and I'm going to need 3 significant figures. I'd be rounding, so how about 11.0 grams of oxygen?